All right, so we're going to do critical numbers today. And it sounds horrible. It's not. They're just called critical numbers because we use them a lot and the important things happen there. But they're not horrible to find. How did mean value theorem end up going yesterday for most people? Okay. Did it seem to work better at that speed I went at? Or maybe that didn't even seem slower to you. I don't know. I see. You guys are full of opinions again. We got to get you woken up. See, here was my key. I filled myself with some sugar, and it woke me right up. That's kind of the cool thing about being an adult. You just go buy the stuff you want and eat it. Nobody can tell you no. Okay, well, I'm going to put some pictures up here. Just random. I just kind of drew different pictures that had different stuff going on. I labeled them just for your sake, but the label, it doesn't matter at all. So like that first one could be a cubic, could be fifth power, it's an odd power polynomial. So if we were to highlight where something happens in the graph, right? Basically we'll call this the math form of, like this is like the action in the movie, right? So where something happens. So like if I look at this one, I would say something happens here because the graph turned around. And then I would say something happens here because the graph turned around again. On this absolute value linear, the v, clearly the only thing that actually happens on this straight line is the fact where the straight line turns around. And on this one and on this one, it's kind of the same thing. And if we look at this was supposed to be like an x to the fourth, but it could be x to the sixth, whatever. Basically it's the same thing in every graph, right? So where something happens, if we were to kind of look at what they have in common, this location has a slope of 0. This one has a slope of 0. This one has no slope because it's undefined. This one is also undefined because it's a sharp point. These are all slopes of 0. So basically, just from these few graphs that I threw up there, what we're kind of supposed to take out of that is that traditionally, excuse me, apparently I ate too many Reese's peanut butter things. Traditionally, when something happens, the slope tells the story of when something happens. Because, like if we're looking at this cubic, these are all positives, positive slopes. And then all of a sudden the slopes get really small, turn to 0. And then the slopes start going to negative and go back up to 0. And then they go back up to positive again. These were all the same negative slope, also no slope, and then positive slopes. So what we're going to take out of that is that whenever the slope is 0 or undefined, that's going to be called a critical number. And it's because that's where something happens in the graph. Now, whatever you guys want to do in your notes, like circle this, star this, highlight it, whatever. So these critical numbers we're going to use a lot. They're going to be part of virtually every problem this unit. And I should say they're part of virtually everything we do with derivatives. So if we're trying to solve some kind of a problem, and it involves derivatives, it almost always is going to involve critical numbers. So a critical number is when something happens, but to find it, it's when the first derivative is equal to 0 or undefined. And I specifically wrote first derivative because if it's the second derivative, it stands for something else. So, any kind of questions on what's up here so far? I'm trying to start slow because this is a big topic. No, actually they're not. So that is something we're gonna end up covering and going over. Let me take that back. They are a critical number. So we're going to have a distinction soon where you might be asked for a critical point. And so an asymptote isn't a critical point because it can't have a point on it. But it is a critical number because something happens there. So yes, an asymptote is a critical number. But I was going to kind of gloss over that for now. So here, let's put up, I just put up two kind of straightforward, simple examples. Notice both of these are the first derivative. So what we're going to do is we're going to try to find critical numbers from just an equation. Right? Picture is something you rarely get. I mean, we can use a picture to kind of verify what we find out, but you generally just can't go by a picture for anything. We need to wake somebody up today. I'm trying to remember who I didn't call on yesterday. Chidera? I don't think I called on you. Do you think you could help me out with this one? So our goal. Oh, you can just you can just speak away if you want. I was not trying to cut you off. Yes. Yep. That's what I would try to do as well. So I'm going to write it equal to 0. And factoring is probably just the most common thing you look for to start with. Now, if you guys need a refresher, it has to multiply to -4, add to -3. And then I brought this up yesterday. Once you have factors equal to 0, you're going to set each one equal to 0. So on this one, we have two critical numbers, 4 and -1. Now, I don't even know if you would think of this or recognize this, but this answer makes sense to me because the derivative is a squared, which means we know that the original function was some kind of cubic. Because when you take the derivative of cubic, you get squared. Well, a cubic, most cubics look something like that. And it can have up to 2 critical numbers because it turns around twice. So that's just us kind of, checking out our answer and seeing if it makes sense. Nice job, Chidera, though. I mean, that's good. That's a good start at 9 a.m. If it makes you guys feel any better, last year I had a 0 hour. So everybody was starting at 7:30 with calc. That's an hour and a half after you guys, and you guys are, I'm going to bet half of you are sitting in bed or curled up on the couch with a blanket, something like that. Anthony, oh, wait. I forgot I was having you guys call on the next person. Chidera, do you want to pick the next person? Wait, I shouldn't ask you. Chidera, pick the next person. Okay. I like how you apologize. Okay, Marissa, are you there? What? You are there. Yes. No. Oh, no, that's no problem. I didn't even think about things like that too. Do you want to answer later? Okay. Okay. What do I do on this problem? Because it's a fraction. I need to find out when this is equal to 0 or undefined. Yeah. Oh, you must... Did you watch the critical number video already? Nice job if you did. That's okay. There is nothing wrong with working ahead. But yes, that absolutely is what you're going to end up doing. So if you guys have a fraction, what Marissa said was set the top equal to 0 and set the bottom equal to 0 separately. The reason we're going to do that is because if you have a fraction equal to 0, well, the only way a fraction is equal to 0 is if it's like 0 over anything. Basically, the only way a fraction is equal to 0 is if the top is 0. So if you're trying to find out whenever a fraction is equal to 0, you can just set the top equal to 0 separately. And if you have a fraction is undefined whenever the denominator is equal to 0. So you can actually set top and bottom equal to 0 separately for a fraction, a rational expression. And they stand for different things, but they're both going to be called critical numbers. So 2x plus 3 equal to 0 would give me x is equal to negative 3 halves. X minus 4 equals 0, I will get x equal to 4. And these would be the two critical numbers, because this is where it was equal to 0, this is where it was undefined. So this definitely answers your question, Bella. This would be an asymptote. So it's a critical number, but it's not going to be a critical point. And we haven't gotten to critical points, but still. How are we on what's up there? I mean, I'll certainly explain anything differently, more, whatever. This is actually going a lot faster than I thought it might. We might get out early today. I don't know if that's good or bad. So we're going to do a full problem. Finding critical numbers of that function. Marissa, is there somebody... Do you guys hate calling on the next person? Is it just because you feel bad picking on somebody else? You've got a cuckoo clock. I haven't seen one of those in a long time. I love it. I definitely haven't seen one of those for a long time. That's cool. Okay, so Marissa, did you want to call somebody or do you want me to do it? Okay. I just hate calling on people all the time because I never remember who I call on. And I suppose you guys don't like doing it either. That's why the dice was such a perfect setup. In the classroom, I had a big castle that I bought on Amazon that you put a pair of dice in and it rolls it for you. And, then I use the dice numbers to call on people. Eric, have I called on you? All right, that's perfect. That is an excellent pick then. How do I find critical numbers? What's the first thing I need to do? Good call. Good call. So derivative f prime of x, 12x cubed minus 12x squared. Do you want to keep going, or do you want somebody else to go? All right. Why did I do that? You're right, but why did you do that? Okay, so I think you mean this correct, but you overlooked the big step. And I'm bringing this up because I know I've seen a lot of people in the past do this. Is the whole point is to make the derivative equal to zero. So if you are trying to solve something equal to zero, factoring is a much easier way to do it. And so you meant that correct, but that's kind of an important part of it. Okay, so then I'm just going to set each one equal to zero. And so divide by 12, take square root, so we get plus or minus 0. And then we get 1. Now, I did actually graph these out ahead of time so that we can kind of verify and check our findings. And this is, come on. Good God, what happened here? All right. So this is what 3x to the fourth minus 4x cubed looks like. And so that's the slope of 0, and that's the slope of 0. Now, this one itself doesn't really do much, but yet it still kind of satisfies what we were looking for. We were trying to find out when something happened in the graph. And so something did happen there. Basically, the graph flattened out, but then went down again. This one, it turned around. And so we're going to use this information, basically like starting tomorrow, is I'm going to start going over what we do with critical numbers. Like, why are we trying to find out where something happens in a graph? And I wanted to stress the importance of this because we're going to use it so much. And you know, maybe this kind of problem seems really easy to you, but these critical numbers, they can get ridiculously hard. I mean, depending on the equation. And so I want us to get comfortable knowing what we're doing with the problem so that when you run into a difficult one, you're not going to kind of freak out and totally feel lost, right? Like, keep in mind the whole goal is to find when the derivative is equal to 0 or undefined. Now, undefined basically only happens when it's divided by 0. So if you don't have a divided by, then you don't even look for undefined. But the undefined is the easiest one to forget about. It's easy to get so used to just equal to 0 that you forget about the other half. Okay, let's go a notch harder. Do you guys feel like you could solve this one on your own already? Why don't you try to do that? Why don't you take a couple minutes, see if you can find critical numbers on your own. And obviously this is intended for no calculator, so just see what you can do. So, Ariana, I don't know if you're done or not, or if you got stuck at a spot or whatever, but do you think you could kind of help me start this problem? Like, kind of guide me what to do first. Okay, good start. Good start. Did you figure out what's the derivative? Oh, wait, what? 2. So you said 2 over what? 3. Cube root, not 3. Okay. Cube root x. You said something else. Okay, I'll pause. I'm having trouble. Okay. All right. Well, I'll help you through the derivative. How's that? Because I think what you did was kind of combine stuff or something. I'm not sure. And maybe you meant it right and you're just saying it where I wasn't following. So derivative of 2x is 2. And then the minus sign means that this is a whole separate term. So I'm going to do that derivative separate. So 2/3 times 3 would be 2. And then x, and then I need to subtract 1 on the power to get negative 1/3. Now, I think this is where you either made a mistake or I misunderstood you. You are 100% correct that we can write this differently. We can write this as 2 over cube root of x. And it's possible that's what you were trying to tell me, and we'll just blame, although it's really sad for me to say 9:30 in the morning is early, because that's not early at all, but it feels early. So this is our derivative, and you can write it either way. I mean, they're both fully correct. Is that part okay with you, Ariana, or did you, or is that what you were kind of trying to tell me? I got it. Okay, got it. I don't know who we should go with. AJ? What should I do here? Like, there's different ways we can solve this. I was just hoping you could tell me one way. I could. I'll be honest, I don't think it's going to help. But I could. And the only reason I say I don't think it's going to help is because the purpose of factoring is normally to solve each one separately. And that just kind of, okay, no, it's not wrong. I mean, it's not wrong to do that. It just won't help us solve quicker. So traditionally, if you factor something out, you're going to want to factor a variable, or maybe you were factoring out just to make it easier or something, But traditionally, you try to only factor out variables because that's generally what helps us. Well, then let me write this like this. Okay, that's what we're trying to do. And the two most popular routes are to make this a single fraction by common denominatoring, or to solve this, we could add 2 over cube root of x to the other side. I mean, honestly, there is actually quite a few ways to solve this. So if you solved it a different way, that's fine. But I would say this is probably the most popular way to do it. And then the reason we can solve it from here is we kind of do cross multiplying, or whatever you want to call it. I'm going to multiply both sides of the equation by cube root of x. And so I get 2 cube root of x equal to 2. Divide both sides by 2. Cube root of x equals 1. To solve this one, I'm going to cube both sides, because the cube and the cube root kind of essentially cancel each other out. And then 1 cubed is 1. So we end up with 1. Yep. Solving this would still get you 1. No. Nope. No, so if you factor it like this, you would set each factor equal to 0. And it still works. It's basically just this first one isn't any answers because 2 is not equal to 0. And then this would get you 1. So it still works. It was just kind of like extra work, extra steps. Oscar. Go for it. Yep. Yep, you can. Oh. Backwards. So the negative 1/3 means denominator. It doesn't do anything about positive or negative signs itself. So like if I plug 1 in here, this technically means 1 over cube root of 1, which would be 1. And so you'd get 2 minus 2, which is 0. If I plug negative 1 in place of x, this means 1 over cube root of negative 1, which is negative 1. And then the negatives turn to a plus, and so that would be 4. So you definitely have the right idea, but I think you did the negative sign kind of backwards in your head, is what I think happened. Yeah, no, that's all right. I mean, you absolutely can solve it from that top one. So for anybody curious, honestly, this is probably how I would have done it myself, is I would have added 2x to the negative 1/3 to both sides, divided by 2, and then I would take both sides to the negative 1/3 power. And that's so that when I do negative 1/3 to the negative 1/3 power, I get x. And 1 to the negative 1/3 power is still 1. So that's probably how I would have done it. Not that that's easier or different. That's just what I'm more comfortable with. But you absolutely have lots of options on solving. Okay, Oscar, I tried calling in you a little bit ago. And what I was trying to ask you was, what are my critical numbers for this problem? One? It'd be half right. It'd be half right. No, but that's a good thought, actually. That only happens when you do square root. So square root of a squared gives you plus or minus 1, but that's a good thought. Maybe I'll just leave it open. I'll leave it open to anybody. What did we forget to do? Because we forgot a step in there. And if you see it, if you see it, Oscar, you can say it, but otherwise, anybody. Aiden, did you see what we forgot to do? It would. We did not look for when x is undefined. So critical numbers are when the derivative is equal to 0 or undefined. Well, this is our derivative. Our derivative would be undefined at x equals 0. it is really easy to forget about the undefined values. So, I mean, like, I'm not even going to put it past myself to do it. So you guys absolutely can always call me out when I forget something too, but it's really easy to forget about the undefined values. So these would be our two critical numbers. And if you got both of those critical numbers on your own from the beginning, great. I mean, that's pretty good. For just starting these, that'd be really good. Yeah. So undefined means a number you can't use. Okay? And so if I have an equation written like this, okay, yeah, I'll just leave it like that. If I have my equation as 2 over cube root of x, I can't use the number 0 because that would be 2 minus 2 divided by 0. And you can never divide by 0 because that's an undefined value. So you're looking for any numbers that would give you divided by 0. And so that only happens when you have a denominator. And a negative exponent means denominator. Whichever x value would make the denominator 0. Yeah, because if this was 2 over cube root of x minus 5, then x equals 5 would be the value that would be undefined. Yep. Feel free to ask questions on this one, you guys, before we go. The next problem is like our challenge problem. So I want you guys to make sure that you feel comfortable asking questions on this one. I'm not going to call this an easy one. I'm just going to call it not the challenge problem. Okay. And honestly, this one is only considered the challenge problem because of your guys' hatred for trig. It's not necessarily that this one is supposed to be difficult. It's just, yeah, you guys hate trig a lot. Or at least I've been told for the last however many years. Do you guys want us to do this together? Or do you want to try it on your own at first? Does anybody have a preference? Because I can give you guys a couple minutes to see how far you can get on your own. Okay, I will do that. I'll give you guys a couple minutes. So it's 9:36. Why don't we say at 9:38? Just see how far you can get on your own. And we'll reconvene. It'd be a good time for me to check my email. Okay. According to my computer, we're at 38. I'd be shocked if you actually had it done already, but if you did, I mean, that's fantastic. So let's start it together, which I think you guys are pretty good at by now, knowing the first step is to find the derivative. So derivative of 2 times sine of x would be 2 times cosine of x. I don't have much room here, do I? Minus the derivative of cosine of an angle is negative sine, same angle, times the derivative of the angle, which is 2. Two cosine x plus 2 sine 2x. I want to make that equal to 0. And it's not going to have any undefined values because cosine and sine, their graphs both just are waves that go up and down. So there's not any asymptotes or holes or anything. So there's no undefined values. So this one we're just looking for zeros. Kennedy, our class expert on trig. Oh, look, I'm going to call you an expert regardless. Why is this one unsolvable currently the way it looks? There's one huge problem with this, huge issue with this problem. I'll highlight it for you, and you can tell me why it's bad. Okay, that worked. Yeah. For us to be able to do any trig problem, the angles always have to be the same. So we can't solve it unless they have the exact same angle size. So this particular one, that's a big issue. Now, the solution to it is actually not difficult, but it requires you guys to look it up. I mean, if you remember it off the top of your head, fantastic. But I think most people are not going to remember the double angle identity from last year. So if you Google it, because there's nothing wrong with that, the double angle identity says that sine of 2x can be replaced with 2 sine of x cosine of x. Okay, well, now at least we have all the same angle size. But now it looks kind of worse. You know, without me calling on anybody, does anybody have a thought as to what we could try to do? It's actually very similar to what we've been doing on all the other ones. Yes, we can do that. So they both have a cosine of x being multiplied. And actually they both have a 2. I don't know if that's going to help or not, but I might as well take out the 2 just because. So I'm going to factor it out. So 2 cosine of x, 1 plus 2 sine of x equal to 0. Now I have something factored equal to 0. So I can set each one individually equal to 0. I'm going to, oh, does anybody want me to scroll back up? I don't know if I went too fast for everybody. So the reason I scrolled up was because once I get it to here, like in my brain, I totally ignore what I did before. And I know that this is like, I've now written it as 2 separate problems I have to solve, which was, you know, unrelated to what's above. But that's why I scrolled up, so that like I can mentally focus on just these 2. Cameron? Oh, sorry. This looks like somebody wrote something. Yes. Cameron, are you, how are you feeling about trig? Oh, are you good at it? Okay, good, good, good. That's actually way more confidence than I expected, so that's good. Virtually everybody I ever call on gave me kind of the same answer that, I can't even remember who I just called on for my trig expert. I think it might have been Kennedy. Uh, how would you solve it from here? Yep. Okay. Cameron, that was perfect. You have become our trig expert. No, I'm not going to call on you for everyone, but that was perfect. So that is exactly how you should set it up. So cosine is equal to 0 at pi halves and 3 pi halves and on. Okay. Now, do you guys want me to go over a few of the details on these? Because I know you're going to need it somewhat soon. Technically, cosine of x is equal to pi halves plus 2 pi n and 3 pi halves plus 2 pi n. Now what that means is the coterminal answers, because it was just a regular angle, the period is 2 pi for each one of them. Does this look familiar? Is this how you guys solved it last year? I'm not sure if that silence is a great thing or not. Sine of x equal to negative 1/2. So you guys, it sounds like you guys usually look at the unit circle. I'm real bad at memorizing the unit circle, so I don't. But I know sine is negative in quadrants 3 and 4. So I'm going to draw my reference triangle in 3 and 4. And to have a ratio of negative 1 over 2 on the opposite and hypotenuse, this would tell me that this is 30-degree angles, because the 30-degree angle is 1 to 2 to square root of 3. And I know 30 degrees is like a swear word, for calc. Everything's radians, right? This is just how I memorize it. So my first answer is pi plus 30 degrees, and 30 degrees is pi sixth. So my first answer is 7 pi sixth plus 2 pi n. My second answer is 30 degrees less than 2 pi. And this would be 12 sixths. So my second answer is 11 pi sixth. And you absolutely could find these out on the unit circle as well. That's why I told you this is just how I know how to do it. Now, we only wanted our answers from 0 to 2 pi. So that would be our 4 answers. These would be our 4 critical numbers. This one is only going to be considered a challenge problem because I have a feeling you guys needed a big refresher on trig. And what usually happens in answer keys is they expect you to remember all of it, and so they're not going to show you any work, they're just going to write the answers. So how about what's up there? How are you feeling on that? Did this at least bring back a few memories of doing trig and pre-calc? Because you definitely are going to need to be able to do that this year. I know, your teacher always tells you that you need to remember this stuff in the future, and then you feel like you never do. But if you would have asked any past calc student, they would have like yelled at you to no trig, because this is usually the hardest part of the class for some people. Okay, I don't know. I feel like I'll stop there. I didn't have any more examples made up. I mean, I guess I could do one if somebody wants me to do one. But otherwise, I'm going to fix Schoology so that the days, they're not going to be off. So all the farther I want you to get now is I want you to do critical numbers in Khan Academy. That's all the farther you should go today. And you're welcome to go farther if you want. But I got questions from some people yesterday through Schoology asking about critical numbers because I don't think they realized we didn't get there yet. So you can work ahead if you want, but do know that you'll be okay if you just go through critical numbers today. And if you've already done that, honestly, you're ahead of the game. So questions, comments, anything? Okay. Yep. Sure. Mm-hmm. You do not have to watch any video if you don't want. So the videos themselves are not, I only assign them just so you can see them on the list. But the videos are 100% optional. So my recommendation to save time for you guys is when I teach something in class, if you feel like you fully get it and you go to do the homework and the quizzes and everything goes great, don't watch the videos because it's just going to show you the same thing. Where the only place that I'm going to recommend the videos is if, one, you're going to try to go back and study your review, or two, you go to do the assignment and maybe there's some details on the questions that you didn't understand in class, or maybe we didn't even have time to get to in class. In that case, then I would go watch the video associated with it to look for details. But otherwise, I do not require the videos, no. I should have done a better job explaining that. But yes, thank you for asking that one during class. Okay, then we'll be done. I'll see you guys tomorrow.